So in this video, let me give you a nice example of an orthogonal matrix. If we have some vector here, and we want to rotate this vector through an angle theta, this rotation of a vector through an angle can be done by orthogonal matrix. So what we're trying to do here is that we have this original vector has coordinates x, y. So we have our vector xy, and we want to multiply this by some 2 by 2 matrix, which I'll call R. And then we're rotating the multiplication of xy by R is going to give us the new coordinates of the rotated vector, which is x prime, y prime. So I can put a subscript theta on R because this is rotation of the xy vector to the x prime, y prime vector. Okay? This will be a 2 by 2 matrix. So this is a orthogonal matrix because the length of this vector doesn't change when you rotate it, right? It was length r, and it's still length r. So the rotation matrix is an orthogonal matrix. So how do we determine what this r sub theta is? We have to do a little bit of trigonometry, so let's do that. If we want to compute x prime, then the angle that this rotated vector makes with the x-axis is psi plus theta. So x prime is going to be r times the cosine of psi plus theta. Similarly, if we want y prime then is going to be r times the sine of psi plus theta. Okay? Just do a little bit of trigonometry, so the law of cosines and the law of sines. So this becomes r cosine psi cosine theta minus sine psi sine theta, right? And this one becomes r times sine psi cosine theta plus cosine psi sine theta, right? So law of cosines and law of sines. And then we know that the x-coordinate is going to be r cosine psi, and the original y-coordinate is going to be r sine psi. So r cosine psi is the x-coordinate. So we have x cosine theta, and then r sine psi is the y-coordinate. So r sine psi, so minus y sine theta, right? And similarly here, we have r times sine psi is y. So this is y cosine theta. And then r cosine psi is x. So that's plus x sine theta. Okay? So we have two equations here. We have x prime equals x cosine theta minus y sine theta. And we have y prime equals y cosine theta plus x sine theta. You can recognize that as a matrix equation. So what is that matrix? We have some matrix, right, times xy is equal to x prime, y prime. And what is that matrix? Well, the first row gives us x prime. So the first row here, right, x prime is equal to something times x. That's the cosine theta. So let me put cosine theta here. And something times y, right, gives us something times x plus something times y gives us x prime. The thing times y is minus sine theta. Okay? The second equation, the second row of this matrix comes from the y prime equation. So y prime is equal to, let's do the x sine theta. So this is sine theta. Plus y cosine theta. So this one is cosine theta. Okay? So this is our rotation matrix. So this one is our r sub theta. Okay. This matrix rotates the vector through an angle theta. Is it an orthogonal matrix? I claimed it was an orthogonal matrix. The rows of the columns of the matrix are orthogonal with each other, right? Cosine theta times minus sine theta plus sine theta times cosine theta is 0. The columns have a unit length. Cosine squared theta plus sine squared theta equals 1. And the same thing is true for the rows. So in that sense, it satisfies orthonormal rows and orthonormal columns. What about the inverse matrix? So the matrix that inverts rotating this vector, this is counterclockwise, that inverts rotating this vector counterclockwise by theta is the matrix which rotates by minus theta, right? Minus theta. So if you change theta to minus theta, cosine doesn't change, but sine of minus theta is minus sine theta. So if you change the inverse matrix, it changes theta to minus theta, and then you get plus sine theta up here, minus sine theta down here. That's just the transpose matrix, right? So r theta inverse is equal to r theta transpose. That's the definition of an orthogonal matrix. Okay, so in this example, I've showed you how orthogonal matrices can do very nice things. In this case, an orthogonal matrix can rotate a vector through an angle theta. Orthogonal matrices are used in a lot of situations in engineering and in numerics. I'm Jeff Chasnov. Thanks for watching, and I'll see you in the next video.